All right, everybody, here we go. Welcome back. So today's lesson continues our series this week of an introduction into what computers are good at and the basic building blocks of the programs that we'll be writing for the next couple weeks. So for some of you that had a little background, you might feel like we're going way too slow. And for some of you that are just getting started, you might feel like we're going off quickly. But what we're really trying to do over the next few days is give you a solid foundation that you can then build upon over the course of the semester. So this topic, computer science and programming, is highly sort of incremental, right? It really builds on itself. If we don't nail down these basics of how our programs work, then it's going to be very, very difficult later for you to do anything more sophisticated or more complicated. So our goal is really kind of, we're looking at kind of like 1, 2, 3 line programs, but we're really trying to kind of do a deep dive into exactly what's happening. Sometimes when you think about how you read and understand and write computer programs, an analogy to human languages is not that bad, right? So for example, when you start learning English or Spanish or Chinese or any human language, you start out seeing it as a series of symbols, a series of characters. And it's important to understand how each one of those characters works, individually, right? Each character in a word. Then, once you become more fluent, and you start to see bigger pieces, right? So you start to see an entire sentence, right? You start to see an entire paragraph. And working with code is not that dissimilar to that. So when we start off, we're looking at we'll talk today about a single character, the assignment operator, and exactly the semantics of how it works, and really trying to make sure that we sort of cement that into your understanding. But later in the class, we're going to be kind of talking about whole paragraphs of code, and you'll start to see broader patterns and broader pictures. And when you've been doing this for a while and you look at a big chunk of code, you start to see sort of, some of the patterns and shapes and like the big chunks that come together that represent sort of common pieces of functionality that work together to have the whole program work. But today, we're still, at the point where we can do these really close reads, which is really nice. So yesterday's lesson was all about establishing variables, telling the computer program, hey, I want to be able to store some data in my program. I'm going to be able to modify that variable as the program goes along. Today, we're going to talk about different operations that you can perform on variables. And this is one of the other sort of computer superpowers, right? Things that computers are really good at that humans aren't as good at, right? Humans, struggle with math. We struggle with sort of repetitive operations. Computers are great at these things. So let's look at, some of the different operators. Again, I will, as always, say that I'm taking questions on the forum thread, and then I'll also peek at the YouTube chat from time to time to look for questions there. So, feel free to flag me down if you need something. All right, so let's go to the lesson if I can find it. All right, so a little reminder. Oh, okay. So what we actually lead off with today is talking about comments. We've already been using these in some of the code snippets that you've seen, and this is not, I'm going to warn you, this is not the first time that we're going to do this in this class, right? In the sense that sometimes when you look at code, you may see something that's not familiar to you, and we hope that you start to kind of like pick this up through context clues, like what is this doing in the program? Why doesn't this seem to have any effect, right? So comments are a part of every programming language, whether it's Java, Python, Haskell. Every programming language has a way for you to embed arbitrary text in your computer programs. And this text is completely ignored by the computer. You can write whatever you want in a comment, and it's entirely there for sort of the human users. The human developers, the people that are writing the code, including yourself, and then anyone that you might be collaborating with. And comments can serve any purpose you want. You're welcome to develop your own style of how you use comments. One of the things we'll be showing you how to do in the future, and one of the things when we start going through some slightly longer examples of simple programs, is we'll frequently use comments to skeleton our approach. We'll say, okay, well, we're going to come up with our algorithm first. We'll talk about what algorithms are in a few days, but that's an approach to solving the problem. So first we come up with a plan. We write down the plan in English using comments. And then we go in and we kind of replace the comments with the pieces of computer code that we need to write to accomplish whatever the comments say. That'll make more sense once we get a little bit farther down the road. But that's one use of comments. And so they're sort of temporary in that sense when you use them that way. They're really there to kind of help you remember what you were trying to do as you build up your program in small pieces. But comments also stick around in code bases. I'll let you enjoy the video that I posted where I go through some code that I work on in a capacity that partly supports this class. Well, I should say partly. It's the code that actually powers all of these playground examples. And show you some examples of where me and the other developers that have worked on this project have left comments in the code and talk a little bit about why, right? What they're there for. You'll see that there's a lot of the code that we've written that doesn't have comments in it. And that's because, the goal is always to make your code as clear as possible so you don't need these extra explanations, but sometimes you do. And then there are, you can look up, let me see here. There are these funny, I'll have to find, people have looked through, I think a few years ago there were some people that got a hold of some of the Windows source code, and they discovered all of these sort of amusing comments in it. Let me make sure this is actually visible on the. It is, okay. So and you can find these types of things online. These are sort of amusing, right? In the sense that, and again, some of these will make more sense as we go along in the semester, but comments kind of, this is one of my favorites, right? So comments can be a way to kind of blow off steam, to embed some humor in your programs. I remember years and years ago when I was at Harvard as a teaching assistant during my my graduate program. There was a class that I was involved with where students learned how to program an operating system. We have a similar course like that at the University of Illinois. This class sort of became infamous within the department. It was very difficult, and students wrote a lot of code to complete the assignments. And at the time, the teaching assistants would actually go through some of the code by hand. So we'd actually read some of it. And not all of it. I mean, students wrote, thousands and thousands and thousands of lines, and so we wouldn't have been able to have time to go through all of it, and that wasn't the right way to test it anyway, but we would read some of it. And there was one group, students worked in teams, and there was one group one year that decided to kind of, try to play a joke on the course staff. They put a comment into some obscure part of their code, and it was directed at their teaching assistant. It said, Amos, if you read this, we will buy you beer. And sure enough, Amos actually did in fact find that comment and was eventually delivered, a certain amount of beer in response. So anyway, I mean, you can use comments in a variety of different ways. Most of them are constructive, right? If they're not sort of amusing and humorful. I have actually seen some pretty funny comments in some of the source code that students submit for this class, right? All right, so. Comments are, not something to be taken lightly. Again, the computer does ignore these, but these reflect the fact that code is both, a communication between you and the computer, but also an ongoing conversation between you and other people that you're working with, right? And particularly when, you start trying to learn a new piece of software, you get hired at a company and they're asking you to develop this thing that other people have been working on for years and years, which is, by the way, the thing that normally happens in the real world. You don't almost ever get to start from scratch. You get hired by some company and say, okay, well, we're working on this product here, you come help out. And you're faced with, thousands and thousands of, maybe hundreds of thousands or millions of lines of code that you didn't write, and your job is to make some small change somewhere. And so comments in the code, along with other forms of documentation, end up being a really important part of understanding how to do what you're trying to do. Okay, so small, digression into comments, but now let's look at modifying variables, right? So, we can modify, there's all sorts of different ways that we can modify variables in our computer programs. And I'll go through, just some of these, on some of these walkthroughs, right? So we have a whole variety of mathematical operators. There's a table that I think I have linked down here. Where'd it go? Okay, here it is. There's a table I have linked down here on the Java documentation that actually goes through some of the operators that are available. So the main ones that we're focusing on for today's lesson are these, and we sort of go through each one of these in turn, particularly the arithmetic operators, adding things together, doing subtraction, just sort of basic mathematical operators. And the unary, some of these unary operators like increments and decrements, and the logical negation for Boolean values, which we talked about a little bit. One of the ones that's a little bit tricky to wrap your mind around, so we'll talk about a little bit right now, is the Java assignment operator. And so let's get into that a little bit. So let's go down here. Where's a good place to play with assignment? Yeah, okay. So, and this is probably one of the more, so I'm trying to refresh this page to see if I can get these spinners to go away. The assignment operators are probably one of the more important set of operators that we need to understand right now. Again, my walkthrough is not intended to subsume the lesson, so I'm skipping over a bunch of things, but I do want to kind of hone in on assignment, right? So again, where did that go? Okay. Nope, that's the homework problem. Yeah, so variable assignment. So this character, the equal sign in Java, let me switch to the light theme. It's a little easier to see, I think. So the equal sign in Java is it's an operator. It does not connote equality. And so the videos and the text go into this a little bit more, but there are two things that are confusing about the equals operator that I think make it sometimes hard for people to understand when they're just getting started. The first one is it's not equals, right? It's an assignment statement. It essentially means assign the value of a variable to a new value. And so it's not, if you're coming from a math background, equals means equality, right? You imagine, working out these sort of complicated algebraic manipulations where I have two things on both sides and I'm trying to determine if they're equal or not, right? That's not what this symbol means in Java. It has a different meaning. And so, again, there are other programming languages that have different symbols for this particular operation, right? Equals turned out to be remarkably popular. I think that's because there were some early programming languages. I don't actually know where this came from, but there were some early programming languages that decided to use equals for this purpose, the equal sign, and that sort of caught on, and a lot of other languages copied it. But there are some other languages that don't use this, right? You can imagine something like this where I have an arrow. That might actually make a little bit more sense, right? Because it's a little bit more descriptive of what's going on. So first thing that's confusing about this equal sign in Java is that it's an assignment operator. It means take the thing on the right and assign it to, take the expression on the right, evaluate it, and assign it to the variable on the left. So that's the second thing that's weird about the assignment operator in Java is the order in which it works. So when we read code, we typically read, from top to bottom, and that's typically how computers will execute the code. We'll look at some ways of altering that flow of execution starting tomorrow and continuing next week. But for now, when we think about how these computer programs work, right, we're basically sort of executing things one at a time from top to bottom. And we execute the first line, come to the second line, come to the third line, and continue on in that way. Now, that's kind of how you would read English, right? And some other languages. There are languages that work right to left, but English works left to right. So if I'm reading text, I read from left to right and from top to bottom. When we read code, a lot of times, we do read from left to right. When we read certain types of statements, we'll typically read them from left to right, and that's how they're designed to be read. But assignment is a little strange, right? Assignment is a place where it's actually better to read the code from right to left, because that's actually how it's executed. So let's look carefully at this one assignment statement. This one assignment statement is very basic and simple, and yet I think if we really dig into it, it exposes all of these different the two different challenges that we're facing here, right? So the first challenge is this algebraic challenge, right, where the assignment operator is not equality. And that hopefully is pretty clear from this example, because I, regardless of the value of I is not equal to I plus 1. That's a mathematical, absurdity, right? So in math, this type of statement, like if you found this on the ACT in the algebra section, right, it would be like, this is wrong, right? This can't be true. But this is a very, very common thing to do in a computer program because the equal sign is not equality. It's an assignment. So how does this work? This means I'm assigning. Now the left side of an assignment over here is a variable, right? That's the variable that's going to receive the result of evaluating the right side. But the way that this is executed is that the right side is executed first. So when I come to an assignment statement, the right way to read this is to first look at the right side of the assignment. Okay, so we're looking over here. So Java is going to evaluate this statement. It's going to evaluate whether it's going to try to evaluate whatever's over here on the right. Now in this case, this is a mathematical expression that has a plus sign, so I'm adding two things together, and then one of the arguments of the plus sign is a variable, so I'm going to take the current value of I, and then the other part is a literal. I'm going to take 1. So I'm adding the current value of I to 1. That's how I evaluate the right side of this. And then I take whatever that evaluates to, and I assign it, moving right to left. I actually don't know what direction it looks like for you, but moving right to left, I reassign the value of I to whatever the result of that expression is. So in this case, my first line, I set I to 10, and then this line, when I evaluate the right side, I is 10, so the current value of the variable I is 10, 1 is the literal. I combine the two by adding them, I get 11, and I assign that to the variable on the left side, which in this case is I. So I, in this case, appears on both sides of this expression. Its initial value gets used on the right side as part of the expression, and then I overwrite that value when I reassign it on the left. And this is totally fine. And I can do all sorts of fun things here, right? I could have I plus I, right? Or I could have 3I, 3 times I plus 1. Precedence works the same with mathematical operators as you would expect from algebra. I could put parentheses in here to make it a little bit more clear, but if I really wanted 3 times I plus 1, I would have to do it this way. So, so the precedence of mathematical operators when you're evaluating expressions in Java works the same as you've been taught in algebra. And again, using parentheses even in cases where you might not need them, right, is never a bad idea. This might be a little bit more clear, right? So assignment, and again, some of you are coming to this course with some programming experience. Some of you are not. Regardless of whether you're here for the learning code for the first time or you're coming back for a little bit of a refresher course, I actually think this is one of these concepts early on that really is worth investing some mental energy in figuring out sort of like, how does this work? What's really happening? And making sure that you're really clear as to what's going on, right? Important thing to understand about assignment, the left side has to be strictly just a variable. So something like this, that again, if we're used to looking at algebra, might look like something that would be okay, is not okay. I can't, on the left side of an assignment operator, I need to have a variable. That's where I'm telling Java where to put the result. I can't have a literal value over here. That doesn't work. I can declare a new variable to receive that, which is fine. I can save it into an existing variable, also fine. But I can't do I can't do stuff like this, right? In Java, that just doesn't make any sense, right? Even if I have two variables, the left side of an assignment has to be strictly a variable. It can't be an expression of any kind. The right side, on the other hand, can be any type of expression that Java can evaluate as long as it also evaluates to the proper type. So let's look at how that works. So what if I did something like this? Now I have the same problem I had yesterday when I was using literals, because what's the problem here? So I've declared I, its type is int, so I've told Java that I'm going to use this variable to store values that don't have a decimal component. Okay, Java said that's fine. You stored 10 into it when you initialized it. That's also fine. 10 doesn't have a decimal component. But then when it examines this line of my code, it sees that this expression over here on the right side, 3 times I is fine. I is an integer value. Multiplying by another integer is not going to produce a value with the decimal point, but I'm adding a value with the decimal point. And so Java is complaining again that this type of expression can't be assigned to an integer value. The same thing would happen here if I did something like that. Just it's really the same error message, right? If I take a integer value and I multiply it by a floating point value, what I get is a floating point value, because I need to keep that floating point component around. I can multiply 2 integer values and add on to integer values, and that's okay. But on some level, if you think about how Java works, or how mathematical expressions work, as soon as I introduce a floating point value into this, the game's up, right? It sort of doesn't matter where I put it. Even if that floating point value doesn't actually have anything after the decimal point, right? So this is sort of weird. 3.0 seems like it's also equal to 3, but to Java, this is an integer value. It's an integer literal, and this is a double literal. And so as soon as the double literal gets mixed up in that expression, the entire expression becomes a double and can't be assigned to an integer. Now, as people pointed out last time, if I make this a double, then I can do stuff like this and it's not a problem. And in fact, doubles I can also work with, I can save integer values to them. It doesn't matter because the variable is prepared to accept a floating point component. Okay, so that was really what I wanted to touch on here. There's a few examples down here. I mean, I do want to make sure people understand this expression, which is an increment. So essentially, there are a couple of types of operations on variables that are very, very common in computer programs as part of basic computer computation. One of them is taking a variable and incrementing it or decrementing it by a certain amount. So in this case, here's how I could do this. I'm taking this variable dollars and I want to add $100 to it. So the idea is that whatever dollars starts out at, it ends up at that amount plus 100 after this line is executed. So again, I evaluate the right side of this. I take the current value of dollars plus 100, and then I modify the value of dollars with whatever that amount is. And so I save that back into the variable that it came from. This is so common that there's a shortcut for it, and there's a shortcut for all of these. So add, divide by, multiply by. If it's a variable being multiplied by a certain amount, I can use a shortcut. I can do this. I can put whatever I want over here on the right, so I could do this too, right? And this would essentially double dollars, right? It says dollars plus equals dollars. So this is equal to dollars is equal to dollars plus dollars. That's plus equals. Minus equals, in this case, is going to leave me with 0 because I'm going to do dollars and subtract dollars, right? Times equals, maybe this gives us the best result. Absolutely, right? I don't know. I got into the stock market or something there. Divide is going to leave me with 1, right? That's dollars divided by dollars. So I have these shortcuts for all of the the operations that modify a variable by performing a mathematical operation on the contents of that variable. And then there are 2 cases that are very special, and those are where I'm increasing the value of a variable by 1 or decreasing it by 1. And these turn out to be so special because they're used when we go through multiple data values. So starting next week, we're going to talk about storing not just one data value in the variables in our programs, but being able to store multiple data values, a series. It's actually called an array. Might have known these as lists in Python, and it turns out that by expanding our consideration to multiple data values, we can actually represent lots of different types of data. But when we work with that type of data, frequently we want to do something to every single value in a series or every single value in a list or an array. And when we do that, we're going to walk through and we're going to go one by one. And so keeping track of which item we're working on, we kind of we want to work on one item, then go to the next one, go to the next one. So we're incrementing something by one. Java and many other languages have a special shortcut for that. So this plus plus and minus minus. I can essentially take a variable and just do the variable plus plus. Now this is a little weird, right? Because this is the one place where it's so compact that there's actually no assignment, right? So here, at least I still have the assignment operator hanging out here next to the mathematical operator that's part of the shortcut. When I actually get down to the increments and decrements, I just dispense with the assignment operator altogether, right? So, essentially I've got this, I can do this, but it's a little strange, right? I told you that assignment, I've got a right side and a left side. In this case, I've sort of made this so compact that I am modifying the value of this variable without even using the assignment operator, right? So dollars plus plus, this single expression will cause the value of dollars to be increased by 1. Whereas this single expression will cause it to be decreased by 1. And again, these exist because they're so common in certain types of code that we'll start to look at next week. But I wanted you to see them and understand sort of that they're there and how they work. All right, so let me jump on to the forum and see how people are. Let's see, do we have questions in the chat? I'm trying to look at. We're going to be using IntelliJ. We're going to be using Android Studio this semester. We'll get you guys set up with that once the time comes. All right, so I don't see any questions. I hope that's good. I hope that the lessons are speaking for themselves at this point. I'll hang out for a few more minutes in case people do have questions. I'm happy to go through anything that you guys saw. I'm trying to think of is there any other sort of cool stuff that we could talk about that's related to this? And not really. It's just sort of fairly straightforward at this point. But again, we're sort of building up in small pieces to the point where we can do some cooler things. But again, I'll be here for maybe 15 more minutes, and I'll monitor the code. When is the first homework that doesn't use the playground? There isn't one. Every homework you do this semester will be done this way, and we've always done things this way. The homeworks have always been done in the end browser editor, and there's a reason for that. One of the reasons is that I actually think that you learn better coding habits from writing code in a slightly less complex environment. I mean, when I sit down to work on a really big project, I get out and I use IDEA for stuff or VS Code, depending on what I'm working on. So I'll use an IDE. But for writing something small and compact like these short snippets, and also even the longer problems we work on, you'll develop some good practices from working in the in-browser editor. So all the homework throughout the entire semester will be done in this environment. Walk through binary negation section. Yeah, let's do that. So this is actually an operator. This is one of the Java operators. And what it does is it takes whatever, so this can only be applied to a Boolean value. So most of the operators we've looked at in this section are ones that are applied to integer values. I don't know, let me see here. Let me see if I can actually add characters together. You probably can, because Java stores characters in a weird way. But let's try doing something like this, just for fun, before we get to talk about binary negation. Yeah, there you go. So you know, great, I guess. I don't know. I mean, I guess x plus plus should be y because it's the next character. But like, if we do like plus equal to 10, now it's a lowercase b because, and this just goes back to that ASCII table, right? I mean, in the ASCII table, the capitals come first and then the lowercase are after that. So when I add 10 to x, I get to, you know, y, z, well, actually, there must be something else in between, right? Because if I added 10, there must be some other symbols kind of hiding in there, right? And so somehow this comes out to be b, which is strange, right? So it looks like you can use these mathematical operators to modify characters. I wouldn't do that because it's strange and probably going to confuse you. And you know, the order of characters is sort of arbitrary, right? But there is one important operator that we're going to use when we work with Boolean values, and that's this negation. And this is one of those things that's going to make more sense in a few lessons. Because starting tomorrow, we're going to talk about decision making using code, and that's where we start to actually evaluate binary expressions and think a lot more about Boolean values and how they get used. But the idea here is that if I have something that's a Boolean value, I can negate it by throwing this operator in front of it. So this is the negation operator. So let's walk through this code, you know, line by line. I'm creating a variable over here called isCS125 awesome. And then I'm assigning false to it as an initial value. So this is my variable declaration and the initial assignment that's happening on line 1. So the first time I print isCS125 awesome, it contains the value false. False and true are my two Boolean literals. Boolean values can only contain either true or false. Now, when I'm doing, okay, and again, this is one of these things where if you're like from math, this makes no sense, right? How can something be not itself? And even if you're coming at this from a logic perspective, this makes no sense, right? And that's because this is not equality, it's assignment. So how do we evaluate this? We start on the right, and we evaluate the right side of this expression. isCS125 awesome at this point stores the value false, but I've negated it over here. And so now what happens is I take false, I negate it, it becomes true. Negation always flips the value of whatever's in the Boolean, and then I save that into this isCS125, back into the variable isCS125. I think I can string together multiple negations. It looks like I can, so I can do like, you know, and it's kind of like not in a sentence. If you have an odd number, it flips the meaning. If you have an even number, it's the same. You would never see this. This is just dumb. This is just me being silly, right? You only use one. If I don't do this, I get the same value. If I flip it, I get whatever the opposite value is. If I started off with true, then I would end up with false. Yeah, so just one, and I present this now because we will see this, right? We'll have cases in our code where we want to make a decision. And so what we're going to do is we're going to evaluate a particular statement in the code. And if it's true, we're going to do one thing. If it's false, we're going to do something else. And sometimes what we actually want to do is do something if it's false. And so we'll write out an expression that evaluates to true. And if that expression evaluates to true, we don't want to do that thing, right? And so instead of testing whether or not the expression is true, you put the expression inside parentheses, put a negation in front of it, and now you've flipped the mean. That probably didn't make a lot of sense. It will soon. Great question, though. Do bit operators? No, we don't get into bit operators in this class. There's just really no need. You'll get them downstream. One of the things that I don't do, and I'll just be honest with you guys about this, is that I don't talk about binary because I don't care. I don't think it matters at this stage. You guys will understand this more as you go on, right? You'll get to points where the binary nature of computers is actually really meaningful. But, you know, I feel like particularly when we're getting started, just getting bogged down and like doing binary arithmetic on binary numbers and understanding how binary works and two's complement, it's kind of like, so, you know, I mean, I'm not saying it's not interesting or important or possibly useful at some point, but it actually doesn't come up in this class in a place where we need to use it. And so we don't get into it. And again, that's just sort of a conscious decision on our part to let that topic be covered later. Here's another way to think about it. From our perspective, if computers actually didn't store data in binary, if they actually stored it in ternary, like every transistor could actually store 3 values rather than 2, it wouldn't make a difference. Computers store numbers. How they're represented deep inside the computer is a topic for a later date. And certainly if you guys are curious about it, you can ask on the forum and we'll talk about it. But it's not, knowledge that we have decided is really important at this point, right? And I think it tends to kind of bog things down at the stage of the class and sort of turn some people off and they get confused. And it turns out, again, like I'm, basically a half-time professional programmer and I don't think about binary ever. It just doesn't come up, So, all right, other questions. So this is not a lecture to respond to that question. This is a walkthrough. It's not required. You guys can come and go. We have lots of different stuff going on every day as part of CS 125. This is just one of the many things that are happening. You don't have to come to this. If you'd rather get help with the homework, we got sessions for that. This is a nice segue into the calendar. Syllabus for the quiz on Tuesday is going to cover this week's material and the first chapter of Coders. So let's go, good segue into the calendar. Let's go to that because I'm really excited to show you guys everything that's happening today. So we have a packed day of sessions that you guys are all welcome to attend. Again, none of these are required, but you are welcome at all of them. Required, none. Welcome all. And everyone has a different topic and a different theme. So coming up right after me, we have another concept review session. So if you guys are still a little fuzzy on maybe some of the stuff we covered earlier in the week, Rohan and Jackie will go through that with you. Nina and Anisha at 1 p.m. for people that didn't make this walkthrough or might want a different take on the material, welcome to go to that. We're still going through our new student sessions, so if you haven't attended one, feel free to attend the new student onboarding with Hyosang and Nathaniel. The Ask Us Anything session with Lou, who's really fantastic. I would just go to that just to hang out with her. She's super cool. Our daily social is being hosted today by Davis and Nikhil, and that's really just a chance to kind of come, meet the staff, hang out, meet other students. And then we have 2 problems to help you out with today's homework if you need a little bit of extra explanation. Hyosang and Long are leading one at 5, and Charlotte and Fiza are leading one at 8. For those of you that might be in other time zones, we're actually in the process of putting together some programming that you should hopefully be able to attend. You're maybe not watching this, or maybe it's the middle of the night, you're tired of getting up or whatever. So starting tomorrow, and I think that'll can kind of continue, you'll see that we have a couple of sessions in the wee hours. And this is really designed for people on Eastern time zones and might work well for people in other parts of the world. Very much appreciate the staff that are helping pull those together, in particular Harsh, who's doing quite a few of them, and it's really fantastic. So tomorrow, if you want a really early start on the homework, Vikash and Jack will go through it at 4. And then tomorrow morning, we have a concept review at 9 and a homework review at 10, and that's before I get back on the camera and we go through tomorrow's lesson again. So again, what we're doing this semester as part of the asynchronous style of this class is we're really trying to give you lots and lots of opportunities to connect with the staff on your own schedule, at your own speed, on your own time, and focused on kind of what you need, right, on that particular day. So feel free to drop in and out of these sessions. Like I said, you're welcome at all, you're required at none. And I think a lot of these are, my sense is they're working out really well. I think, helps break up the crowd a little bit and gives you a chance to have some more individual attention. We'll also be setting up our help site soon where you'll be able to get very, very individual attention. Give us a few more days on that, but that's coming. So in the meantime, still a lot of opportunities to get help with CS 125, learn more, interact with the staff, ask questions, meet fellow students. That's happening pretty much all day. All right, let me go back one more pick. Yeah, so I'm happy to add, well, why don't you give me 5 more minutes, and then if people are still around at 11:50, I'll do a small discussion of kind of the tech stack of the website and some of the other pieces that we use. Yeah. So let me just make sure that I've nailed the part about characters. So let's go back here and we'll go back to our variables and types, because I think that's where the ASCII table is hiding. And okay. So remember before we took Z and we added 10 to it and we got B. Well, what happened here is that there are these punctuation symbols that are hiding out here in between the. Now I don't know who put. Somebody came up with this, right? That's what I love about the ASCII table. Like, some human being, sat down one day and was like, hey, let's make a table with all the characters in it and some other random characters. And it's like, there are certain things, you might wonder what all this stuff is here over on the left. These are different characters for controlling a terminal. Like, for example, there's a bell character, okay? This is character 7, right? Do you know what that character does? That character is supposed to cause the terminal to ring a bell, like ding, right? So we got a character for that. We don't have like a proper dash as part of this, which is sad. There's the little dash right here, but that's actually a hyphen, not a real dash. But we do have a character that causes the terminal to ring a bell. I don't think that character works in our playground, but you're welcome to try it. Maybe we should add that just as a little bit of like an Easter egg built into the website. But again, like some human being, I don't know who came up with this, just sat down one day and was like, hey, let's assign a number between 0. We have 128 numbers to hand out, and we're recruiting characters. And I don't know how they came up with this. So why is there, why did the capitals come first? Why is there this weird stretch of punctuation in between the capitals and the lowercase? Why are there certain operators and not others? Who knows, right? It's just lost to the sands of time, right? But at some point, somebody sat down with this, and now we're stuck with it, right? And obviously we've moved forward, and we have new ways of representing characters now that are much more flexible. But certain types of computer systems are still, like the Java character, for example, is still living with these limitations that were introduced a long time ago. All right. So again, if I start with X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I get to B. All right. Back to variable operations. Comments. I think. Let's go back. Check. All right. I think. Oh yeah. So character. It's the question was about typecasting with characters. I actually think that's a good question. I almost wish that I didn't have to teach the character type, because they're just so weird. They don't follow a lot of the rules that variables are supposed to follow in terms of casting and stuff like that. I don't know why characters, you can perform mathematical operations on characters. I think that's a little peculiar. And so, next week, we're going to get into how to work with text in Java. And the character type at that point is going to be one of these things we're going to forget about, right? We're going to kind of put it in the dustbin and move forward with our lives. And honestly, that's probably the best use of the character type, right? If you look at the 8 primitive types that Java came up with, 7 of them are arguably useful, and then there's the character type. And that one could probably just go away. So we introduce it now. It's fun to be able to store single character values, but once we start to have a way to work with entire strings, which we'll talk about next week, and multiple character values, that's actually much, much more valuable. And Java strings can actually also store, a much, wider range of values. And so we can actually put foreign character sets in there and all sorts of fun stuff. And Java is okay with that. So the character, I would argue, is just a very, very limited, it's a very limited thing. And so I wouldn't get too concerned about its behavior at this point, right? Because we won't be working with it seriously for too much longer. Yeah. So great question. Let's go back and look at this. This is another one of these things that's weird about characters, right? So why can I do this, right? Why doesn't this happen? Well, actually, if I put this in quotes, it's not going to work, right? It only works if I take the quotes out. And the reason for this is that characters are storing a number. And Java allows me to assign them from a number. Now, again, I don't know why that's the case. It would be a lot more clear if what I did was this, right? But, since this was yesterday's lesson, let's go ahead and just solve the mystery. So we're going to print out the value of mystery, and let's assign it to 56. It prints 8, okay? Why? Here's my ASCII table. 56 corresponds to the character 8. Let's choose a different one just for fun. Let's do 43, okay? I get a plus. Now there's some over here that aren't printable. So let's try Bell. I don't think anything bad's going to happen. Yeah, it just doesn't print anything, right? Bell's not a printable character. In fact, this whole group over here, on the left side, until you get really to 32, these are all, I think, usually considered unprintable. I guess there's a few that are like new lines or form feeds, those in backspace, right? Those might be printable, but in general, the printable part of the ASCII character set is mostly over here, with the exception of a few places. But again, what I really want you to take away from this is that characters store numbers internally. Everything in the computer is a number, including the character. And when we print it, what we're seeing is this convention, this mapping that, again, some person came up with, probably 50 years ago. We're seeing that in action, right? So let's pick another one. Let's do 113, maybe. Now we get Q because 113 is over here. So that's why I don't have to put it in quotes, because I'm actually not assigning a character literal. I'm assigning an integer value. And I'm allowed to do that because characters are weird. Now, I guess one thing, and I actually don't know what will happen here. Let's see what happens if I do this. Ooh, that looks cool. Okay, maybe characters are more exciting than I thought, right? Because why does this work? Possible lossy conversion from int to char. Let's try this. Okay, there seem to be some strange, what about if I use a negative number? Okay, well that it doesn't like. So it looks like there's some interesting things hiding out here. I don't know what that's supposed to be. I don't know if it's wrapped around, or let's keep trying and see what happens. Let's try 128 plus 35. Sorry. Yeah, I don't know what this is. This is weird, but clearly there was some. If I assign values that are outside of the range, now what if I do 257? Okay, I'm still getting strange things printed. So I don't know. If you're curious about this, we can look into it and try to figure out what's going on. I really am not sure. Certainly, obviously negative values don't make sense for character types, but it's not clear why I can assign these larger values at all, right? It's also not clear why I can't use. Let's try this. Okay, well that's okay. I guess I don't know what these are. So anyway, this one almost looks like a couple of little masks or something. But characters are sort of an oddity. We'll get past them soon. Hopefully that answers your question. Yeah, some of these might be. Yeah, so the car value can only store a single character. That's one of the limitations of it. On the other hand, it's similar to all the other primitive types in that sense, in that it can store one value. All the primitive types we've looked at store one value. Characters are no different. We will start to talk about how to store multiple data values next week. All right, so I'm done with the main. You know what? The people who are asking about the website, let's feel free to post a forum thread on that, and we can talk about it there. I don't want to get into it right now on the live stream, because I think it's a strange and difficult transition from the questions that we've been handling. So anyway, good luck everybody today on the lesson, on the homework. Finish that up. Keep in mind that we have a lot of we have a lot of fun stuff going on today. It's part of CS 125. Other things for you to participate in. We also have the extra credit opportunity, filling out your profile, finishing the Gravatar step. It's not that hard. It does take a few minutes to update once you put it up there, so don't expect it to happen immediately. But get all that done, and you'll get that 1% extra credit, which is pretty useful and really great for us, right? To get to know you a little better and be able to see your face rather than just a letter. All right, I will be back, same place tomorrow.